modus.
Hello and welcome to our today's event. We're doing StarWind Virtual SAN breakout session, Hyper-converged storage for Hyper-V. My name is Max Kolomeitsev. I'm StarWind Virtual SAN product manager and I'm your host for today's event. Before we begin, let's do a quick sound check and video check. So I would be really grateful if you provide me with some audio and video feedback and tell me if you're getting good picture and if the audio connection is sufficient to conduct this event. You can drop your feedback to questions and answers panel of the GoToWebinar. Okay, first feedback, second feedback, third feedback. Okay, we're good to go. Right. So a little bit about myself. Currently, I'm the StarWind Virtual SAN product manager. Previously, I had more than 7 years of quality assurance and technical support experience at StarWind Software. And before that, I worked in a storage-related company for about 3 to 4 years. So that gives me about 10 plus years of IT experience. And as you can see, I'm also hosting StarWind Technical Webinar Series as well as this breakout session. Right. Here's a brief agenda for our today's event. So first, we're going to have a small StarWind feature overview, then we'll do an overview of our today's demo stand, and then of course see StarWind Virtual SAN in action. And at the end we'll also do a Q&A, so you'll be able to ask any questions you may have about the software, and I'll gladly answer them. So what is StarWind? I mean, most of you have already read something on our website or watched previous webinars we did or seen some documents. But in a nutshell, StarWind is a VM-centric software-defined storage solution. The idea is to take industry standard servers you may find on Dell's website, on HP's website, IBM's website, well, basically any vendor you like, and install Windows on them, or install VMware on them, and then install StarWind on them. And StarWind will take the local storage, mirror it between the servers, add additional features to that storage, and present it back to the same servers as a single shared storage resource, which is highly available, which is much more VM-centric than just plain local storage, and provides some additional showtime features like replication, snapshots, inline deduplication, and stuff like that. So let's go through the bullet points here. I already covered the hardware agnostic design, so that's our philosophy. StarWind can run on any server hardware, and as long as it fits our system requirements. Now, the second main point is the high availability. So if you're a small shop and you realize that your RTO and RPO are really strict and you want to run your environment seamlessly, you want resilience in your configuration, that is the moment where you jump from a local storage and backup type of scenario where all the virtual machines or all the applications just run on the local storage, and then you back it up from time to time. You move to a different concept where you leverage that local storage capabilities and create highly available storage from your local disks available in the servers you're already running. That's the main concept of the high availability. If we get into more details, the high availability we offer is not just having a standby copy of your data available should a failure occur. Not really. We do much more than that. The idea is to mirror every single write you do to the storage and only acknowledge that write when it physically hit all StarWind nodes which participate in the cluster. Now, we do not only acknowledge the writes which happen to the disk to make it much faster, since we don't really want to have enormous response times waiting for each disk in the cluster node to acknowledge that write. We keep RAM cache on each node coherent. So we also synchronize RAM cache. And basically it's a distributed write-back cache which is truly non-volatile. So should one node fail, the configuration continues running and the cache is preheated on the other node. Should it be a 3-node cluster, 2 nodes can fail and the 3rd node will continue running and the cache will be intact. At that time, StarWind will switch from write-back to write-through mode to preserve the data and prepare for shutdown of that 3rd node. But the reality of it is that in a real 3-node system, you always have at least 2 copies of your RAM cache available and all the I/O is extremely fast. Now, the next point here would be the VM-centric file system, which is LSFS, or also called log-structured file system. So the idea here is to get the most of each storage component you can put in the server. So what we do with LSFS, we take all the IO blender, all those random writes going through from the virtual machines to the storage and convert them from little random writes to one big sequential write. As a result, we're not looking for disk IOPS anymore. We're actually looking at raw disk throughput at this point, because all our writes are essentially sequential, and if it comes to reads, the idea is to add a layer of flash to that server and use flash as an absorber for all reads happening to that server. With most virtualization environments where the writes read distribution is about 65% write up to 80 and 90% write in VDI scenarios, these type of storage works really well. And also, we designed it to be flash friendly from the very beginning. So with flash treated only for read cache, there is no continuous I/O stream going to the flash disk. So we eliminate spot burns, we prolong flash life with this type of setup, and we also get maximum performance from both spindles and flash. Now on top of that, that storage also facilitates thin provisioning and snapshots, which is a must-have for today's storage solution. Now, a synchronous one replication, it's a very neat feature to have when you don't want to replicate per virtual machine, or you don't want to do an SRM configuration for VMware where you want to replicate the entire LAN or the entire virtual machine set from one location to the other. There is where our asynchronous WAN replication kicks in. You can take 1 meg pipe and replicate your primary site to a disaster recovery location. So you can have as many nodes as you like on the primary side, and then let's say have a virtual machine running on the disaster recovery side, and that virtual machine will keep the replica of the information you have on the primary side. Now, the replication does not always squeeze all the information on the disk to the offsite location. It's intelligent. It does incremental replicas, so it only makes an initial replica once, and then it replicates the delta according to the schedule you've set. One additional feature we offer is a virtual tape library. This one allows to leverage the capabilities of local spindles and cheap SATA and create a virtual tape library and attach it directly to the virtual machines running on that server. So a lot of industries have compliances and they have to store tape backups, or they have to back up to some sort of tape and then store that backup for a really long time. So this is where virtual tape library becomes really useful. You don't really need to have the physical tape library at this point. You just use your underlying storage, let's say a cheap SATA RAID 5 attached to that server will be used as your main backup. And that also brings in another concept, which is so-called D to D to T, which is disk to tape backup. So you back up all the virtual machines from their local storage to another local storage resource, which is really fast. And then once everything is backed up and secure on the SATA drives inside the server, you just do a tape backup, and you don't really care about the tape backup window at this point. Your virtual machines continue running, their performance is not impacted, they're not affected in the middle of the day, and essentially you're still under compliances, but everything is much better. Now at the end I would say that everything we're talking about is not just limited to 2 or 3 servers in the setup. We're starting with 2 servers as a really minimalistic setup, and we can essentially scale out beyond 64 nodes in this type of configuration. So adding each node will give you 33% more storage and additional compute resources. And that also can rebalance your cluster. So once you add additional node, mirror it with the existing nodes, and then the new virtual machines will be spawned on that new node, and will use the local copy of that StarWind shared data to store their information and run the applications within the virtual machines. Now, I guess we'll not be doing a death by PowerPoint today, and that was a little too much information for that slide. So let's switch to the next slide, which is our demo stand overview. Right, so today we have 2 servers participating in our setup, and these 2 servers run Windows 2012 R2, and these also run StarWind Virtual SAN. Now StarWind takes the local disks, as I mentioned, mirrors it using standard Ethernet, and then presents it back to the system as a single shared storage resource. So that's a basic explanation of our today's breakout, and at this point we'll be switching to the live demo part of the show. And should you have any questions for the presentation part, I'll gladly answer them during the transition. Stay tuned, we're about to change the screen. Okay, we are now inside the StarWind Management Console. As you can see, we have 2 servers here. These are participating in our today's Hyper-V cluster. and have already pre-configured the quorum for our cluster, and I have already configured one of the cluster shared volumes for the cluster as well. Now, cluster-wise, here is our failover cluster. We've got the same nodes I mentioned in the StarWind Management Console running here, HVN1 and HVN3, and we've got the storage I provisioned in StarWind listed here. So we've got a cluster shared volume and we've got a quorum, and we also have one virtual machine which is on pause right now, stored on the cluster shared volume. Now let's get back to StarWind and see how we actually provision storage from our side. So the idea is to simplify the whole process, so the person who manages the storage doesn't really need special storage skills to provision storage and attach it to the servers. So here is a virtual entity called StarWind Cluster. It is not related to the Windows Failover Cluster. It is domain agnostic. It is just a virtual entity which simplifies the creation of the cluster storage within StarWind and makes it easier to attach that storage to the local cluster nodes. So as you can see, we have these two devices which I mentioned here. We have them here as well. So if we want to add more storage to that cluster, we just right click on it and press create cluster storage. Let's say it will be CSV2, and we'll give it something like, let's say 25 gigabytes. Going next, we can go thick provisioned at this point, or we can thin provision our storage and optionally enable deduplication. I'll go with thick provision this time, and then select the participating nodes. So we have 2 nodes in our cluster. Should we have more nodes, we just move more nodes to the right and mirror between more nodes. Press next. And we press finish. Okay, at this point our CSV2 device is created. It will now do a quick synchronization, and as soon as it's synchronized, we'll be able to connect it to our client cluster. Like, you know, previously when we had StarWind version 6, the clients had to go here, open iSCSI initiator, go to discovery, type in all the IP addresses and stuff like that, go here, get everything connected properly, and then initialize the storage in the server manager. Now that's all yesterday. We're simplifying that process, so soon you should be able to get StarWind storage attached to the cluster right after you create it within the StarWind Management Console. Okay, so CSV2, yeah, it's doing that synchronization now, and our cluster is ready and waiting for new storage. Now, I mentioned that we just used local storage for the high availability devices. I'm getting the disk management on the screen now. Okay, there it is. There is a new disk. Let's do a GPT-4 now. Okay, so we have our disk 0, so that's the SATA drive we're using for the demo. Here is the Windows operating system as well as StarWind and StarWind image files. Now we have disk 2, which is our cluster quorum, and disk 3, which is the cluster shared volume. Let me actually try to extend that volume now. Okay, that's better. Not sure about this guy though. It looks like someone stuck a USB drive in the servers we're running the demo on. Okay. So essentially there is no external storage attached to that server. We go to the C drive, open it up, then let's see. Let me actually open StarWind Management Console to see where the devices are stored. Yeah, my computer, C StarWind Quorum image, and then C StarWind CSV image. Now this guy is, yeah, it's doing a synchronization. It's about 1 minute left. So we go back to the C drive, open StarWind, and this is how our high availability devices and basically all StarWind devices look in the system. We've got them visible as image files for the OS, and they're treated just as files on the local storage. And if we're looking at something like L2 flash caching, which StarWind now officially supports, you add a flash disk to the server, you create a partition on it, and then StarWind's flash cache will be visible as a file on the flash drive and treated by StarWind as it is a separate cache layer. Okay, we should be finished synchronizing now. 93, 94, almost there. Come on. Oh, there you are. Okay, so it's now synchronized, and what we do, we just press add connect storage on the servers. So let me just do this. Let me show you what it looks like in the iSCSI initiator. So once we refresh, we have those devices inactive. Okay, and within StarWind we press connected to the cluster. Now it's connected to that cluster. We can also scroll right and see the status of each storage, see their synchronization status, and these are the servers where the storage is connected to. So at this point we're all set with StarWind. As you can see, it took me something like 10 minutes or less to tell you about it and configure the storage. If I were doing it on my own without needing to explain it to anyone on the side, I would spend something like 3 to 5 minutes to provision highly available storage for that cluster without any additional storage hardware. Okay, so we add a new simple volume, sign a letter, yes, 64K, and finish. Okay, we're good to go now. We've got a new volume available on one server, and let me just double check if the second server has the same thing available here. Okay, computer management. And here, online, yeah, an error, and now it's offline, online, yeah, there you are. Okay, we're all set with initializing stuff, and we can now go back to the cluster, go to disks, and add one more disk. And here it is, our 25 gigabyte HA device I have just created. It's available here. We press add, and we've got that new disk available in the cluster. Now, let's move on to the actual failover test. Okay, there's a virtual machine. We're logging in. Yeah. Something happened. Okay. And let me quick open IMeter and just do some testing. So we'll put some load on the system, and let's, yeah, it won't be big. It's 10 kilobytes, 100 meg, 10 megs, 100 megs, gigabyte. Okay, at least a gigabyte to do our IO test. Got one CPU here, okay, and we'll be doing 4K read, 4K write for this particular one. We're not really expecting huge performance from this configuration since it's plain SATA and just some RAM caching on top, but it should still provide us some results, and it should show us that the configuration is actually running. Okay. Right, so we now have some I/O going on here, and what I will do, I'll go to the HVN3 machine, just minimize it like this so we can see it, and our second VM here. Okay, and what we'll do on the second node, let's say we'll start with a basic thing. We go to services and say that StarWind iSCSI SAN, for some reason our software failed on one of the servers. So we stop the service. The virtual machine is still there. There is a temporary I/O redirection which IMeter treats like 0 megs per second, and here it is back again. At that moment, StarWind says connection lost to one of the servers, and let me get the console back so you can see how it looks like. We've got partner node is not ready warning, and when we actually hover our mouse over the image, it will tell us what's wrong with the partner or what's wrong with that particular device. We cannot get to HVN3. Our cluster nodes are still operational. It's still running properly. And let's see. We go back to the second server and we fix it. Right? Okay, so there is StarWind iSCSI SAN back up and running. Now you see the performance jumped down a little bit because StarWind started an automatic synchronization. So we can see that here. There it is. The cluster shared volume. Yeah, it takes seconds to synchronize that, even with the virtual machine loading that SATA. Okay, commencing countdown. 4, 3, 2, 1, launch. Okay. And now our high availability device is reconnected. And there you see the MPIO switch, and 2 nodes are back up and running. And all this time virtual machine stayed up, and it didn't actually care about if the storage is available on that node or it is not, because StarWind handled the replication in the backend. Now, the HVN3, let's stop StarWind once again and see how we handle one more thing. So we've got connection lost, we've got our virtual machine switching over to the second path right now, okay, and let's see, we want to move that machine to a different node. Now it's doing a live migration to a node which doesn't have the storage instance available locally, but that's not an issue as well. That storage instance is available via iSCSI should the local storage fail. So the virtual machine continues running even if one of the servers has the storage array failed. Okay. Now let's fix our software again. Wait for another synchronization and actually restart the whole cluster node. So that's maybe the whole purpose you're looking the high availability for. You want to have that level of resiliency. You want the virtual machines to run fast, smooth, and have them quickly restarted should anything happen to either of the nodes or either of the server components. Okay, StarWind is now doing an automatic resync. Let me double check on that process. Okay, fast synchronization, less than 15 seconds remaining. Right, and one more time, we'll be doing a full failover test right now, so we'll be restarting one of the cluster nodes, and the restart procedure will give us probably 2 to 3 minutes to talk. So should you have any questions, feel free to drop them to the questions panel, and I'll gladly answer them. Okay, so the virtual machine is running, and what I'm going to do, no, that's not the right one, I guess D. Yeah, that would be the most reliable way to restart the server. That was a command? No? No. Oh, /R, of course. Okay, we're now restarting the server. It says shutting down and signing me out shortly. Yeah, the session already hanged, so it's about to throw me off. Okay, and we have some questions in the questions panel. So let me get down to these. Okay, let me expand that. Don't have a lot of screens running here, so it's kind of converged here. Okay, so the first question is from Harry. What is the difference between the thin and thick provisioned disk? So the thick provisioned is the legacy flat image file design. So that's allocates all storage once you create the device, and we treat all I/O in the classic way. So I mean, we do not have a non-standard file system for that. Now, the thin provisioned one is the LSFS I mentioned previously during the presentation. So that is the log structured container which is virtual machine oriented and provides great performance compared to basic flat for virtual machine workloads. That's not something you'll be actually seeing with one virtual machine, but if you put some real IO Blender workload on that type of device, it's going to be much faster and the latency is going to be much lower. Now, next question is from Peter. If I run a Hyper-V cluster and use StarWind as storage, will it be supported if I call Microsoft? Yes, it will be supported if you call Microsoft. Microsoft actually does really good job supporting mixed configurations, and I'm really glad to say that last time I had a call with Microsoft and we have troubleshooted a common issue between StarWind and Microsoft Failover Cluster was about 1.5 years ago, and with current number of Hyper-V deployments, I guess it's already beyond 30,000 deployments for hyper-converged failover cluster scenarios. I guess that's a good sign. Okay, Frank asked us a question. Can I use Microsoft Target or have to use Target created either StarWind tool? You cannot really use Microsoft Target, but you can try to convert it with StarWind converter. You can convert VHD files into StarWind images and then export them using StarWind. As another option, if you have multiple servers, you can just do a storage migration of the virtual machines or your data from the Microsoft Target container to the StarWind container. Now, a question from Justin here. When deploying StarWind to the nodes, can you deploy to all at once or have to install each individually, taking localhost? We do have an automated installation procedure, and I guess that's covered with our PowerShell manual. So I guess that's something I can give a detailed explanation, but not throughout the webinar, but rather in an email. So feel free to email me or just support at StarWind Software or starwind.com, and we'll gladly help you with that. Now, a question from Andrew. Are you able to move thin to thick down the road? Actually, I think we can do vice versa. We can do thick to thin, but not actually do thin to thick. The reason for that is because the containers have different layout. So thick provisioned device has standard, it's like NTFS, every block has its fixed place on the disk, and LSFS is a log structured file system, pretty much like NetApp Waffle, but just without the magic hardware behind it. So it's really hard to migrate from non-structured data to a completely structured data. So that is possible. We can do that with no downtime, but it's not a button which says convert thin to thick. It would be moving the data on the client side, doing a storage migration from a thin device to a thick device, and then doing the same on the second node. Now, another question from Frank is, the disk 2 is a virtual machine created on disk 1C, correct? Not sure about that. Let me just check with the remote session I have here. HVM3. By the way, we wanted to look at the failover. With all these questions, I forgot about the failover. So let me actually get to the failover cluster manager and show you the virtual machine which failed over to the other node. Okay, there it is. Our virtual machine is up and running right now. Can connect to it. Okay. Now load at this point. We're good. So the VM restarted successfully, and we can now get our first node back. Let's see. Let me remote into it once again. Okay. Where is it? Oh, there it is. Okay, did not reconnected, and okay, StarWind actually has resynchronized at this point. Yeah, so I can see we left the configuration unattended and just recovered from node loss without us actually helping it. So I have a few more questions here which I will probably answer down the road when we have the Q&A session, and I guess that was all for our today's demonstration. I will definitely do more sessions like this in the nearest time, so look out for StarWind Digest coming into your inbox and showing more interesting events. Like on 9th of October we'll be doing a webinar with Five9 on Hyper-V security in a hyper-converged environment, so some of you may find it interesting. You can definitely attend that event as well. Right, so now we are switching to our final part, which is the Q&A. So here are some questions which I didn't answer last time. So Hank asks us a question: is it possible to have flash rate 0 as L2 cache to saturate 4 10 gigabit network? Will that help the write also? Not really, because flash L2 cache is something you can saturate really quickly, and once it's saturated you will still have that spindle speed to kick in. So that is definitely possible with the log structured file system if the underlying storage can get you a stream speed of something like 4 gigabytes per second. So if your L1 storage will be able to give you that speed, then L2 cache might work for that. But I would say that is specific on the workload. Now, one more question from Frank. Is StarWind target creation tool available online? Indeed, StarWind can be downloaded at starwind.com/StarWind Virtual SAN. You can get a 30-day trial. Look at it, see if it works for your particular environment. And of course, we do offer free technical support for all trial users, so feel free to contact sales department and seek for assistance in configuration. We'll definitely help you out. I would also like to mention that we do offer a complete set of services. So with your purchase you have the installation and configuration service included. So the idea is that you buy the software, we install it for you, we configure it according to our best practices, we connect it to your hypervisor, and we make sure it works properly before letting you to production. Now, one more question from Peter. Do you have examples of IOPS and transfer speed for different hardware setups? That is actually something I'm working on right now. We should be publishing a document using standard hardware and performance referenced. I would say that with the last performance metrics I've seen was a 8-drive SAS SSD RAID 10 in each StarWind server, and that gave us something like 84 to 85,000 IOPS in a round-robin HA configuration. So that's the numbers I remember from the top of my head. I would say that SATA would give us something like 2,000 maximum for a 12 disk, near like 7.2K drives. But intermediates are not really in my memory right now. So should you need more information or some IOPS samples, we can definitely provide you with that if you shoot us an email. Now, a question from Claude: what is the pricing for StarWind Virtual SAN? Unfortunately, I cannot disclose that on the webinar. I would say that the price range is from something like $900 up to $10,000, but for each particular case, for each particular capacity, and for the amount of nodes you're running, the license cost is calculated differently. So you can definitely contact sales and they can give you up-to-date information on the StarWind prices, and that's not a problem at all. Now another question from Charlie. Why should I use StarWind instead of a classic SAN? Okay, so the idea of classic SAN is to have a central hardware unit in the configuration and then have multiple hypervisors accessing it. That idea is good. You can have a fault-tolerant SAN. The thing is that once you try to expand it, or once you try to upgrade your configuration, it becomes quite painful and complex. So StarWind, what we do, we leverage the performance of the local storage, because now you don't have that slow link between the SAN and the hypervisor. All the I/O happens locally and is only confirmed with the partner node's write-back cache, so that's really fast. And with that I/O path shortened and latency reduced, StarWind achieves much better performance with the same set of drives compared to a standard hardware SAN. Because at the end of the day, hardware SAN has longer I/O path and it doesn't really have a cache which is closer to the client. So I mean, even having a write cache on the SAN does not protect you from write spikes which accumulate on the hypervisors and are then bottlenecked between the hypervisor and the SAN. So with StarWind, all the cache is kept local, so you never hit the network directly. You always hit the disks, and you always have a pillow of write-back cache, both RAM and flash, between your storage and your application, but you don't have that bottleneck of proprietary storage fabric between the servers. Okay, how does StarWind compare with Sears DataKeeper? As far as I remember, DataKeeper is oriented on replicating data between 2 or 3 servers. I didn't look in that product for about a year now, so I'm not sure about the up-to-date feature set, but I would say that StarWind is designed as a virtual SAN, and it does provide virtual SAN functionality. DataKeeper's functionality was a little different, and it was rather oriented on applications which were not cluster aware, and you had to replicate the data between that particular applications. I can definitely provide you with some more detailed information should you send us an email with that question to support@starwind.com. Okay, a question from Frank. Is a target considered as a virtual machine? Not really. A target is just some space of the disk you allocate to the cluster, and then that space is allocated to the cluster, converted into a cluster shared volume, and then a virtual machine is provisioned on that storage. So technically you can have tons of virtual machines within one target. So that does not linearly correlate. Okay, a question from Boniface. Does StarWind support both software and hardware iSCSI initiators? Indeed, StarWind does support both. The only thing is we do not really need a hardware initiator in this case, because with a hyper-converged setup, StarWind bypasses all the TCP stack and routes all I/O to the local storage. So that simplifies that path, and that allows us not to use any hardware iSCSI initiators. And by the way, with modern CPUs, hardware iSCSI offload is becoming less popular, because even with 10 gig networking and no iSCSI offload, we see something like 2 to 3% CPU utilization. So unless it's a really dense environment like VDI, that's not really a mandatory thing to have. Okay, a question from Peter. What is the minimum license for a 2-node Hyper-V cluster with local disks? A minimum license for a 2-node Hyper-V cluster would be a 1 terabyte license. Then we go with increments. I guess it's 1, 2, 4, 8, 16, and unlimited. Okay, I guess that was all for today's questions. I'd like to thank everyone for spending some of your time to see the session. I will try to get the recorded version of this event on our website soon so you can share it with your friends, colleagues, and management. And